Polynomial expressions are those that involve some unknown quantity, a variable, in this case x. We have multiple terms that are being added or subtracted in the polynomial. Those terms are constructed by taking whole number powers of the variable x. So in this case, I'm cubing it or taking it to the third power. I'm allowed to multiply it by some real number coefficient. In this case, the term x cubed its coefficient is 5. And then I'm adding or subtracting those terms to create a single algebraic expression. We prefer to write our polynomials in standard form. That means the highest degree term will appear first, and then the lower degree terms will appear in order. In this case, I see 5x cubed. That's the highest degree, so I'm going to write that one first. The next term I see is this degree 2 term with a coefficient of minus pi. I'll write that next. Then there's a degree 1 term, so you should think of this as x to the first power. So we add that term in, 3x. And then there's a term here that has no power of x, at least visibly appearing. This is a constant term, and it will appear last, so minus 2. This expression is now in standard form. The first term is the leading term, and its coefficient is called the leading coefficient. The leading coefficient in this case is 5. The degree of the polynomial is the degree of that leading term, and in this case, the degree of our polynomial expression is 3. You may be a little bit concerned about this constant term because it doesn't have any x appearing in it. But just to illustrate this, minus 2 itself is a polynomial expression. It's minus 2 times x to the 0. So you should think of that as a degree 0 polynomial. Constants are degree 0 polynomials. We can perform various operations with polynomial expressions. For example, we can add or subtract them. Let's look at an example of subtraction. Let's take 4x cubed minus 2x to the 5th plus 1 minus x. That's a polynomial of degree 5. And I'm going to subtract that from the polynomial 2x squared minus 3x to the 5th plus x cubed plus x plus 1. Observe the use of parentheses here, particularly on the second polynomial. It's minus this entire expression. In order to perform the subtraction, we're simply going to combine any like terms, that is, terms with the same degree. In the first polynomial, I'll rewrite this in standard form. Minus 2x to the 5th plus 4x cubed minus x plus 1. And then we're going to distribute the minus that appears here through each term, changing the sign of every term and removing the parentheses. It'll be minus 2x squared plus 3x to the 5th minus x cubed minus x and minus 1. We now compare each degree. The highest degree I see is degree 5, and so I'm going to combine those terms. It's 3x to the 5th minus 2x to the 5th. That leaves me with 1x to the 5th left over. We've taken care of that highest degree term. I now look for the next degree that I see. It's going to be x cubed that appears in either polynomial. So it'll be 4x cubed minus x cubed will give me positive 3x cubed. There's a degree 2 term in the second polynomial, but not in the first term. That just means that that remains exactly as it appears, minus 2x squared. We then look for degree 1 terms, minus x and minus x gives me minus 2x. And then observe that 1 and negative 1 cancel out, so add 0 for the constant term. Strictly speaking, I don't need to write the 0 or even write the coefficient of 1 in front of x to the 5th as that's implied. So I'm just going to clean it up, and I have x to the 5th plus 3x cubed minus 2x squared minus 2x. Let's look at an example of multiplying two polynomial expressions. I'll take 2 minus x squared times 3x minus 5. In order to do the multiplication, I need to distribute each term in each polynomial against every other term in the other one. So I need to take 2 times 3x. I then need to take the 2 times the minus 5. That results in minus 2 times 5. I then need to take the two terms here, minus x squared times 3x. And then I need to multiply these two last terms, minus x squared times minus 5. We then simplify the expressions by multiplying their coefficients together and simplifying any powers. So in the first case I have 6x minus 10. In this case, the degrees add together and I get minus 3x cubed. And then I get plus 5x squared. Rewriting in standard form. And we're done. You may observe the order that I did the multiplication of terms in is somewhat standardized. I took the two first terms from each polynomial expression and multiplied them together to get the first product. I then took 2 times minus 5. They're on the outside of the two polynomial expressions, so we call that product the outer product. I then multiplied the two inner terms together. And then I multiplied the two last terms together. And so together this is first, outer, inner, last, often abbreviated as FOIL.